Hi viewers, welcome to my channel. Today I am discussing about the how to find out the chlorides in water sample in the laboratory. Yes, let us what is the chlorides? Where we can find the chlorides that we have to know. So here the chlorides in water can come from the various sources that includes natural sources, human activities and contamination. So what is the natural sources? Natural sources means it means weathering of rocks and minerals. And next, what are the activities from human activities are industrial process, waste, water, and road salt. And next is contamination. Contamination is from leaching from nearby industrial sites. These are all naturally. These are all the sources which we will get the chlorides from. These are the sources of the chlorides in the water. And next, high level of chlorides in water can indicates. It means if the presenting chlorides limitations across the limitations as per the WHO, it indicates the pollution is contaminated and the corrosion of the pipes and infrastructure also damaged and water treatment issues are occur. Yes, let us see the how many methods to find out the chlorides in the water. So we have various methods to find out the chlorides in water. So here we have some methods. Those are the titration method, ion chromatography method, spectrophotometry method, and electrochemical method, calorimetric methods. Okay, these are the 5 methods to find out the chlorides in the water. So here I am using only the titration method, and I will explain those methods also. Ion chromatography method is it is based on their charges and the sizes of the chloride ions, how many ions are present in that, that's based on their charge. And next, the spectrophotometry, measuring the absorbance of the light by chloride ions at a specific wavelength. So we can find out the absorbance of the chlorides. It means that is based on the color of the chloride contains it means it reacts with any some other chemicals. Like that, we will take the observance from the spectrophotometric, we will get the chloride ions. And next is fourth one is electrochemical methods. This is used for the electrodes to measure the electrical potential generated by the chloride ions. We here also we have the finding the some reactions. What are the reactions find present in that, like that. So and next is the calorimetric methods. This is also the depends on the observance only. So we are getting some chemical reactions to produce the colored compound that indicates the presence of the chlorides. It means take the some wavelength and adjust the wavelength in the calorimetric, and we will find out the chloride absorbance, and from that only we will find out the chloride amounts, how much amount is present in the in the water sample. We will find out from this method also. So these are the 5 methods, but here I am using only the titration method, that is argentometric method. It means the argentometric method means we are using here silver nitrate. So silver nitrate is AgNO3. So AgNO3, so that's the reason we will call it as the argentometric titration method. So here I am using that method only. Yes, let us start the experimental procedure, how to perform the chloride experiment. So here we are taking the apparatus are required. Those are the conical flask, burette, pipette, and beakers. Okay. So here the first step is take the sample is 5 ml, 5 ml or 100 ml also. Take the 5 ml of sample in the conical flask and add the potassium chromate. It is an indicator. Add the potassium chromate and also the 0.05 molarity of the silver nitrate. 0.05 molarity of the silver nitrate. Okay, 0.05 molarity of the silver nitrate take into the burette and so that what is the sample is in the yellow color, right? That is the yellow color. How we will get the yellow color? The indicator color is the yellow color. That yellow color is indicator is adding to the water sample, that will get the yellow color. The solution is in the color of the final end point is red color, brick red color. But in the middle of that we will get the we will get the precipitation as silver precipitation of silver chloride formed. Okay, so that will in the color of the white color. So here we have observed some reactions here. Whenever we add the chromate indicator to the sample, that we will titrate against the silver nitrate, that will form as the Ag to CrO4. Okay, right. So that Ag to CrO4 as form as a precipitation, and then after we will add the reaction is get silver plus chloride, that will form as AgCl, that will get the color of the red color. So we are finding that red color is the final end point of the silver nitrate sample. We will get the how many chlorides, the amount of chlorides present in the water sample, we will calculate that. Okay, whenever the titration against with the silver nitrate, the in the sample we have some chloride, that chloride is titrate reacting with the Ag, and we will get the AgCl, that we will get the white color precipitation. Whenever we observe that, we will get, and next that remaining Ag is reacting with the chromate CrO4, we will get the silver chromate. Yes, let us start the experiment here. The chemicals require silver nitrate and the potassium chromate. So take the burette, fill the AgNO3 silver nitrate in the burette, fix to the retard stand, and take the conical flask and okay, and take the sample. I collected here, the sample is 50 ml. Here we have taken the sample is rainwater sample is 50 ml, and next add the K2CrO4 indicator to the water sample. Take the 1 ml or 3 drops or 4 drops to the sample. After adding the indicator, we will some titrate, empty titration is required. And next start the titration against with the silver nitrate. Just take the drop by drop only. We have to keep the drop by drop only. The burette is observe the here the brick red. Observe the here the brick red color. We will get the brick red color of the sample. So stop the procedure to do the. So here take the observation table, draw the observation table and take the sample. Here I have taken the 100 ml sample, and burette readings are initial reading is 0, final reading is 2.8. Take the two trials. I'll do the two trials, trial to 2.8 and 5.4. The final volume of the AgNO3 is consumed here, the 2.8, and next here it is 2.6. okay, let us substitute in the formula is, this is the formula. Chlorides we have expressed in the chlorides in the units of mg per liter, and the formula is volume of AgNO3. It means how much consumed in the burette, that the volume of AgNO3. Next the normality of AgNO3 into 35.45 is multiplied by 1000 divided by volume of sample taken. How much you have taken, that only you noted in this formula. So here I have taken the volume of sample is 100 ml. Yes, here I am doing the first trial. 2.8 into normality is I prepared the 0.1 normality of AgNO3, so I have taken that only 0.1. And next is 35.45. It is the molecular weight of the chlorides. Okay, and then next the 1000 divided by 100 or 50 ml. Here I have taken the volume of sample is 100, that's why I have written the 100, or else 50 also taken. Okay, next final. So trial 1 value is 99.26 mg per liter. Next take the trial 2. The trial 2 value is 2.6, right here 2.6. So substitute the 2.6 in the formula and calculate this. We'll get the value is 92.17 mg per liter. So this is the trial 2. So take the both the average of this both trial 1 and trial 2. So 99.26 plus 92.16 divided by 2, we will get the value of the chlorides ion concentration of the given sample rainwater is 92.17 mg per liter. Okay, This is the final value. And also we have some limitations for the drinking water, that is less than or equals to 250 mg per liter chlorides present in the water, it is used for the drinking. If it is greater than, we will use it for the domestic purpose only. Okay, so this is all, these all about the chlorides which is present in the water sample. Clear about it. If you have any doubts, please comment it. Okay, thanks for watching. Subscribe to my channel.